All right, so welcome to our first pre-cal video. We're starting right at the beginning with section 1.1, day one, and we're going to move through the entire course this way. One of the things for you to keep in mind when you're watching these videos is if you're playing with your phone or you've got something else going on, you're going to be distracted. The best way to watch these videos is to treat it just like you're in class taking notes. Turn everything else off, pay attention, write down the things that I write down, think about questions that you might have during the video and write those down, and then just make sure that you pay attention and that you take it seriously. We're going to go ahead and get started. We're going to start with a review of the real number system. Hopefully you remember that real numbers are basically any numbers you can think of. Those are real numbers. Um, we're going to go through rational numbers, irrational, integers, whole numbers, and natural numbers just to remind you what they are. There's a small diagram over here on the side that kind of shows you how they're connected. You can see that all natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers, and then all rational numbers and all irrational numbers combine to make up the real numbers. So we'll start out with the rational numbers. Those are numbers that can be written as a fraction. You can remember that because the word ratio is in the name. So numbers like 1/2, -2/5, 2/3, which is also equal to 0.666 with the bar on top, so the 6 repeats on forever. That's also a rational number. Even though it's not written as a fraction, it can be written as a fraction. Another example would be 0.125 because that's equal to 1/8. So that can be written as a fraction. Irrational numbers are numbers that cannot be written as a fraction. So a great example is the square root of 2. That can't be written as a fraction. If you punch it in your calculator and get the decimal, it's just going to go on forever. There's not going to be an end to it. Square root of 3 is another one. And we can keep going. There's a lot of square roots that are irrational numbers. One that you are familiar with but may not realize is irrational is the number pi. It's 3.14 and it just keeps going. There's no end to it. It goes on forever. So that makes it an irrational number because we can't write it as a fraction. An integer, that's a number that you would think of if you were counting or doing math problems. So they start way down at negative infinity and they just start coming up -3, -2, -1, 0, 1, 2, 3, and then it just keeps going on to positive infinity. It goes on forever. Those are the numbers that you typically work with when you're doing math problems. And these are also the numbers just to think of as counting numbers. Now, whole numbers begin at 0, and they include 1, 2, 3, and they go on forever in the positive direction. But they start at 0, so that's the key. Negative numbers are integers, 0 and up are whole numbers. Natural numbers are exactly the same as whole numbers, except they start at 1. So that's a quick rundown of different types of numbers. A couple of words we need to learn is relation and function. So a relation is a rule that relates to quantities. That's just basically it tells you how two things are related. A function is a little more specific. Okay, a function is a special relation that assigns one element from the domain to one element in the range. That's a fancy way of saying that for every x, there is a y. So every x matches up to one element in the y. So if we kind of look down at this little table we have, if these were the x's and these were the y's, you can see that this x matches one y. This x matches one y. This x matches one y. It's the same y that this one matched, but that's okay. That's not what the definition was. The definition said that each x matches up to one thing in the y. So if you can remember that about a function, you'll be good to go. A function can be represented lots of ways. It can be numerical, verbal, algebraic, or graphical. So verbally, there's typically a sentence, and it describes how the inputs and outputs are related. Okay, so it's just going to be a sentence, and it's going to be something like the output is 2 more than the input. Okay, so that means we put something in, add 2 to it. The answer is whatever we put in plus 2. We can do it numerically, and typically you'll see that with a table or ordered pairs. So you might see an XY table. You have 1, 2, 3, 4, 2, 4, 6, 8 of a function. Or you might see 1, 2, 2, 4, 3, 6, 4, 8. And really, if I list them out like that, I should have commas in between all of them too. Okay, graphically is another way that you'll see functions represented. And that's going to be with points on a coordinate plane. Some examples you might see. Draw a couple of little coordinate planes here. So you might see a set of points like that representing a function. You might see some kind of curve, and you might see a line representing a function. So all kinds of different things in a graph can represent a function. And the last way you might see a function represented is algebraically. An equation relates the x and y coordinates of each ordered pair. And this is probably the way you're most used to seeing it. You might see, quick example, y equals x plus 1. Okay, that's an algebraic representation of an equation where the relationship between the inputs and the outputs is that the output is 1 more than the input. And we could graph that into a line like this, and we could make it into a table or a list of points like this. Something that you may have seen already is called the vertical line test. The vertical line test is a way to determine whether or not a graph is a function. So a couple of quick examples up at the top here. If you see a graph that looks like this, well, the vertical line test says to come along and just draw a vertical line through it. And if you can draw a vertical line through it and have it only intersect your graph at one point, then that graph is the graph of a function. So you might have one that looks like this. And you come along and you draw your vertical line. It only intersects at this one point, so function. The ones that are going to not pass a vertical line test are going to not be functions. So you might see something like this. We draw a line through it, vertical line. It hits it in 2 different points, so that's not a function. And we'll practice this a lot and have a lot of examples. So real quickly, let's do some quick examples and determine whether or not the following are functions. So we're going to decide yes or no, are these functions? So on the first one, I look at it and I see that when x is -8, y is -5. When x is -5, y is -4. X is 0, y is -3. X is 3, y is -2. X is 6, y is -3. Good job. That's a function. Okay. Let's look at this one, which is gonna not be a function. So -6, -7. When x is 2, y is 3. When x is 5, y is 8. When x is 5, y is 9. That's a problem because we have the same x value or the same input producing 2 different outputs, and that's not okay. So this is not a function. We look at C, draw a vertical line through. We have the same input 4 producing 2 different outputs, one up here and one up here. So this x value of 4 has 2 different y values, so that's not a function. Move over to our squiggly line. Vertical line test. Everywhere we draw it, we're good. So that is a function. And come over here. We've got -2 right off the bat goes to 2 different values. So that is not okay because we have one x value that's producing 2 different y values. So that's not a function. Another way that we can determine whether or not something is a function is algebraically. So if we take a look at these equations we have here and we put them into the y equals form, we can see what they're gonna do and what they're gonna look like. So let's start with this one. So we get 2y equals negative x plus 8 divided by 2, and we get y equals negative 1/2 x plus 4. Now hopefully you know that's the equation of a line. In fact, that's the equation of a line with a y-intercept of 4 and a slope of down 1 over 2. So I add that line to the graph just so you can kind of get an idea of what it looks like. And we can say that that is a function, okay? Because if you made a table of x and y values, or if you came up with the points that were along this line, you would always find that for every x value, there's only one y value. So we'll take a look over here. Y squared minus 2x equals 5. So let's get to moving stuff. All right, now we have this situation. Hopefully, with our little algebra review, we remember to square root both sides, and we'll get y equals plus or minus square root of 2x plus 5. Well, that's an issue because if y equals the square root of 2x plus 5, that's good. We can put a number in for x, and we get an answer for y. Everybody's happy. But if y also equals negative square root of 2x plus 5, if we put a value in for x in each of these, we're going to get two different values for y. And what that looks like when we graph it, this is a pretty simplistic little graph, but just bear with me. When we graph this one, y equals square root of 2x plus 5, we're going to get something that looks like this. And that alone by itself is a function. But when we put in the other part, y equals negative square root of 2x plus 5, we're going to get something that looks like this. And then immediately we should see that this fails the vertical line test, so it's not a function. But anytime you come up with a situation where your y can equal two different things when you put in the same value for x, that is not a function. Doesn't mean it's not something we're going to work with, it just means it's not a function. All right, last one. So up until now, you've probably wrote most things as y equals, but we're going to start using something called function notation. In function notation, the symbol f parentheses x parentheses, just like this, is read f of x and interpreted as the value of the function at x. So when we see y equals x squared plus 5x plus 6, the function is f of x equals x squared plus 5x plus 6. And that just basically means f of x and y is pretty much the same thing. So if you make a table of values, the y values are your f of x. So I got a few example problems I'd like you to work, and we're going to go over them in class tomorrow. But go ahead and work these out. Basically, you just need to take whatever it says f of 3.2 and plug 3.2 in everywhere there's an x and find the value of that function. Little tip, if you plug in something with an x in it, you are gonna end up with an answer with an x in it. So don't get frustrated and think that you have to make it say x equals. Do what you can to take it as far as you can, and then remember, the hardest thing to do in algebra is to stop. That's it. See you tomorrow.